So coming to the regular classes only, it might be the last class. So in the last class, we are discussing regarding the OpenCV. So OpenCV stands for, it is a computer vision package. It's an API only. So whenever you want to work on image detection problem, image processing kind of things, here it is a very good package. For image processing kind of things, it is a very good package. So after finishing this class, I will forward you the I will forward you the book in your WhatsApp group. So after that, yeah. So I did not explain you the additional contents regarding machine learning. Those are what is k-fold class validation and what is linear analysis and what is principal component analysis. So coming to the k-fold class validation, coming to deep learning, what we are did. So here to obtain the best result, we are going with the mini batch stochastic gradient descent approach. So whenever you want to converge to the global minima to reduce the cost function, what we are applying mini batch gradient descent. Like that, in the machine learning algorithms, if you have huge amount of data, so on such cases, you need to train a machine in faster manner. So for that purpose, we have k-fold class validation to get a best accuracy to train a machine with a different number of folds. For that purpose, we have k-fold class validation. So if you are interested, go through that thing. So if you go through that thing, though you won't understand something, message me. I will explain you. I will explain you by taking one session, or else I will forward you the. So here, that is about k-fold class validation. So coming to next thing, but principal component analysis. So finally, after performing all the algorithms, what we are doing there, we are plotting the graph. We are plotting the graph. To plot the graph, if you have more than two columns, what happens? So it is unable to. So there is no possibility to draw the graph between all the feature with only one output variable. On such cases, we need to take help of principal component analysis. That is nothing but from the entire data set, we need to consider top two features or best two features. For that purpose, we need to take help of principal component analysis. After that, we have one more approach, that is linear discriminant analysis. Yeah, sorry for the delay. Yeah. Next one is the linear discriminant analysis. So let us assume in your data set you have more than 20 columns. So to process that many columns, so on the 20 columns, there might be some useless columns like person names, person age. So sometimes we need not to consider those parameters. So to eliminate such kind of parameters, we need to take help of linear discriminant analysis. Till now, we did not perform out that linear discriminant analysis as well as PCA. So in place of these techniques, I explained you the EDA, that is exploratory data analysis. Exploratory data analysis means we are visualizing the data based on, so we are comparing each and every feature. So after that, we are plotting the correlation map. Based on that correlation, we are considering few features till now. Whereas if you don't want to see the such kind of visualization directly, if you want to, so if you want to know the behavior of each and every feature, better to go with linear discriminant analysis. So such regarding, so whenever in your project this kind of things involved, so there if you won't understand anything, contact me while explaining the projects. Monday onwards I will explain you the project batch by batch. Monday onwards I will explain you the project batch by batch. So coming to the today's class, yeah, we will discuss OpenCV, that is a computer vision package. So here where, so I kept that thing in intent folder. So continuously we are working on this folder only. So here in the OpenCV, I kept a lot of codes. So here I created one OpenCV. You see here, if you observe, I kept a lot of images in it. So here you can directly specify the image name. So here I specified a lot of images. So here we have image 1, image 2, image 3, so on dash. I kept a lot of images. So here after these images, so here if you don't have images at the same working directory, you can specify the file path also to read the specific image, to perform the specific operations on the image. So here I kept all the images at the same folder or same working directory. So here I wrote each and every program in this file only. So here it is about the OpenCV. So, CV stands for Computer Vision Package. Whenever you want to import the OpenCV, here we need to import this thing by using import CV2. So here import CV2 is the to open this OpenCV. Before this thing, so if you execute this thing in your laptop, it will return module not found error. In your laptops, if you execute this statement, it will return module not found error. So for that, what we need to do? So you need to install this platform in your laptop. So to install this thing, we have different ways. So if you are using Anaconda, so for that command is conda install. So here OpenCV will be supported for different programming languages. So here it is an API which is supported for C language, C++, as well as Java, as well as Python also. We need to install the OpenCV platform which is corresponding to Python. So here I'm installing OpenCV corresponding to Python. Here I'm saying OpenCV. So here I'm saying OpenCV. After specifying OpenCV, we need to specify the environment. So here I want to specify the environment, that is contribution. So here I'm saying contribution Python. So here I'm saying this thing. So here it is a command to install OpenCV in Anaconda prompt. So if you try like this, if it returns error, so if you try by using this command, if it returns error, so in the Anaconda you can install same thing by using pip command also. So here in place of this conda, use pip. So if you try this command in the Anaconda prompt, if it returns error like so if it returns error like pip is not recognized or pip is not found, if it returns error like pip is not found or pip is not recognized, before that thing you need to install pip. So here before this thing, if it returns error like pip is not found or pip is not recognized, try this command conda install pip. So initially we need to install pip. So these are the, so here first initially we need to install pip. After that you can try this command. So or else directly you can try this command also. This will also works. So pip install OpenCV Python. So here this command also works well. So whenever you want to install OpenCV Python version, here this command also helpful to you while installing this OpenCV. It is about installation. After installing this thing, now we will see how to perform different operations on the images. So here how to perform different operations on the images. So here in the book I specified each and everything, whereas here I am specifying few operations. Initially what we need to do, we need to import this computer vision package. Whenever you want to import this vision package, we need to specify CV2 only. Whenever you want to access computer vision package, import CV2 is the command. So after that I want to read the image. So here we have few function like image read, image write, as well as image show. So whatever so these are similar to the matplotlib functions only. There is no that much difference between matplotlib functionalities and this thing. So here initially we need to read an image. So whenever you want to read the image with the same resolution, means if you want to read the original image, here we need to specify 1. So whenever you specify 1, by default it will read the image with the colored format only. Whereas in place of this 1, if you specify 0, in place of 1, it will read the image in the form of grayscale manner. That is nothing but black and white image. So it will consider only one channel if you specify 0 here. So here now I want to calculate height, width, and shape of the image. So for that purpose, so if it is a color image means here we have 3 channels. If it is in color image means we have 3 channels. I want to know dimensionality of each and every channel. So here shape of 0, which is nothing but height. So if you want to know the height, here we need to specify index 0. Whenever you want to know the width, here we need to specify the index 1. Whenever you want to know the number of channels, so here how many channels are there, if you want to know the number of channels, we need to use index 2. So after that, finally I want to know the size of the image. So here it is like numpy syntax only. So here I am knowing the size of the image. So after this, initially I want to know the image height, that is nothing but I stored in height variable. After that width, after that I want to know the number of channel. Finally I want to know the size. Size is nothing but, it is nothing but number of pixels present on that specific image. Number of pixels corresponding to that specific image. I am running this entire code. So whenever you run this code, here I specified image one. So image one contain height of 480 centimeters or pixels, and image width will be 640 pixels. And the number of channels, here we have 3 channels. Those are BGR, blue, green, red. So after that, the number contains total 92,000, sorry, 9,21,600 pixels. So here it is about knowing the information of the specific image. So after that, how to reshape the image. So here, how to reshape the image. To reshape the image, what we need to do? We need to reduce the height as well as width of an image. If you want to reduce the image pixels, if you want to compress the image, what we need to do? We need to reduce the pixels. So here, I want to reduce 100 samples. So here, I'm normalizing this image by taking by 100 on the height as well as width also. So after that, I am finally observing the dimensionality with the reduced features. So here I am reducing the features. After that, I am knowing the dimensionality. So whenever you want to perform resizing the, yeah guys, can you please wait for 3 minutes? I will take small break. Okay, done. So here, what I am doing, I am reducing the height and width of the image. After that, I want to know the dimensionality. To perform the different operations to reduce the image pixels, we have resize function. In this resize function, to reduce the features of the image, we have interpolation attribute in this resize function. So here, which kind of interpolation you want to perform, you can specify that interpolation name. So here, we will discuss this thing briefly in the upcoming programs. So whereas it is coming to the very basic program. And finally, I want to show the resized image. And here I want to, so here, whenever you want to write the program, we need to close that specific image. After watching that particular image, we need to close that image. So here, for that, we need to use wait key attribute. So in the wait key attribute, we are specifying 0 means, so whenever you press any key, whenever you press any key, then this image will be terminated. So that means it will proceed to next step. That is nothing but destroy all windows. Whenever you press any key in your laptop, then destroy all the windows. That means image will be closed automatically. So here it is my resized image after performing interpolation. So we will see all those features within few minutes, and we will see this program after discussing all the programs, all the basic program. We will start with very basics. After that, I will come to that this picture. So how to perform different kinds of rotations on the image. So I will come to that at the last. So here, initially what we need to do, initially, whatever the operation you want to perform on the image, initially we need to import CV2 module. After importing that module, we need to read the image. In the read image, here, if this image present at the same working directory or same folder, we need to specify that image name. So if it is belongs to the another folder, if this image is present at another folder, we need to specify complete file path. If it is present at different location, we need to specify complete file path. So after that, so here it is about reading the image. In the reading the image, we need to specify the image name with the extension. After that, we need to show that image. That is nothing but we need to show that image in the output. For that purpose, we have IAmShow function. IAmShow is a function which is used to show the image. So which image we need to show? We need to show the image which we read previously. That's why here I'm specifying image. After that, I want to press any key to exit that window. So here I'm saying wait key equals to 0. So here, whenever you perform different operations on the image, so after performing different operations on the image, if you want to save that image, we have IAmWrite function. Whenever you use IAmWrite function, so you need to specify file name, new file name with the same extension. So here I'm performing some operations on this image. Here I did not perform any operation. Directly I'm saving, so I'm reading this image. After reading that image, directly I'm saving that image with the different name. So here we performed operations on this image. That's why here I'm specifying image. So after that, finals, after saving that image, we need to destroy all the windows. So here I'm running this portion. So whenever you run this portion, so here it is my original image. So here after obtaining this image, I'm clicking any key. So here I entered enter key here. Whenever you click on the enter key, that program will be automatically terminates. So here this program automatically terminated. And if you observe same working directory, so here in the same working directory, new image will be created with save image with the name of same save image. Here new file will be created. So here saved image.jpg. It is the image which is created now itself. So here IAmWrite is a function which is used to save the image after performing different operations on the image. So after that, we will say how to perform different operations on the image. So how to reshape the different, so how to perform resizing operations on the image. We have different kinds of reshaping. One is cubic interpolation, one other one is area interpolation, as well as linear interpolation. We need to perform all these operations on the image. So for that, initially I'm importing computer vision package. So here I want to use NumPy module also. So here I'm importing NumPy module also here. So here after that, I am reading the original image. After reading that image, I want to show the original image for the first time. So I want to keep heading as original image. On top of the image, I want to show like original. And I want to show the image which we read previously. After that, whenever you press the any key, I want to terminate this image. That means I want to terminate original image. After that, I want to resize the image. So for resizing the image, it is the syntax. Here what I am specifying, initially we need to specify our source image name. After that, we need to specify output image size and in which dimension you want to print the image. After that, you need to specify X scale, that is nothing but height, and Y scale, which is nothing but width, and which kind of interpolation you want to perform on the image. So initially, I want to perform cubic interpolation. So here, whenever you want to perform any kind of interpolation, we need to use resize function. So in resize also, we need to specify image name. So here, I'm specifying image size as none. That means by default, it will take original image size only. So on the x-axis, I want to take the image of 75% of the image. And on the y-axis also, I want to reduce y-axis with the 75%. And this kind of interpolation is called as intercubic interpolation. This kind of interpolation is called as intercubic interpolation. So after that, I want to show that image. After performing this operation, I want to show that image. So I want to keep heading as cubic interpolated image, and I want to show the image which is scaling cubic. We stored this image in scaling cubic variable. So here I'm specifying scaling cubic in IAmShow function. So after that, whenever any key is pressed in your laptop, we need to terminate this image. We need to proceed for next step. So here I want to perform area interpolation. Area interpolation. Whenever you want to perform area interpolation, you need to specify the output image size. So here I'm specifying the image size. So after that, I am specifying the output image size, and next I am specifying the type of interpolation which I use it here. So after this, I want to show this plot name as area interpolated image, and scaling skewed. In the scaling skewed, I stored this output image. That's why I'm specifying that variable name here. After that, we need to close that image whenever you press any key in your laptop. That's why here I'm giving wait key. So after that, I want to perform linear interpolation. Linear interpolation means if you reduce the image with on the x-axis with the 50%, if you reduce the image on the y-axis also with the 50%, that kind of interpolation is called as linear interpolation technique. So here, in between the two features, we are removing one feature, that is nothing but linear interpolation. This thing is called as interlinear interpolation. After that, I want to show that image. So after that, if you press any key, we need to proceed to the next step, that is nothing but next image. So whenever you press any key, this image will be discarded, and next step is, after writing all the programs, we need to destroy all windows. We need to close all the windows which are opened previously. For that purpose, we need to use destroy all windows function, which is present in OpenCV. I'm performing this operation. So here it is my original image. So after this original image, I'm clicking on any key in my laptop. So here I'm entering enter key. So whenever you enter key, so here it is cubic interpolated image. So here whatever the title we kept in imshow function, that will be displayed here. Cubic interpolated image. That is nothing but 75% reduced image. So after this, it is area interpolated image. Area interpolated image means here we specified the output dimensionality rate 600 cross 300 image. So after this, again I'm clicking on enter key. So here whenever you click on enter key, here it is a 50% reduced image. That is nothing but linear interpolated image. So these are the different images which we got while clicking any key in your laptop. So after that, what we need to do? So after grabbing all these informations, we need to click on enter. So whenever you click on enter, this all images will be destroyed. This all windows will be destroyed. I'm clicking on enter button. So here whenever you click on the enter button, all the windows are destroyed from this. So here if you want to know the syntax of any function, or if you want to know the description regarding any function, what we need to do? So go to that specific function. I want to know about resize function. I'm going to here. After that, I'm typing shift tab. So here I want to know the working of this resize function and how it is designed. For that purpose, I entered shift tab after executing that session. So here, if you see the description, if you want to see the description regarding that function, you can read the description here. So here, shift tab is the way to see the working of any function and how it meant and what is the purpose of that thing. So here, it is about seeing about specific function. Till now, we performed interpolation operation on the image. Now, we will see the different kinds of rotations of the image. So how to flip that image, how to flip horizontally, how to flip vertically, and how to flip both the sides at a time. So for that purpose, here we have flip function in computer vision. So here flip function, we have flip function. So initially what we need to do, we need to read computer vision package. After that, we need to read the original image. After reading that original image, first time we need to show that original image. After that, we need to press any key to exit that specific image. After that, we need to use flip function. So in this flip function, if we specify number 1, so here in the flip function we have a lot of attributes. Those are 0, 1, -1. So these are the major attributes you need to remember in this flip function. If we specify 1, it means the image will be flipped horizontally. So here whenever you specify 1 in this flip function, the image will be rotated horizontally. So here after performing this operation, I want to show that image. After flipping that image in a horizontal fashion, I want to show that image. So here I want to show that image. We stored that image in flipping. So whenever you observe the output, so here it shows us flipped image. After that, it needs to wait till pressing any key. So after that, I want to flip that image vertically. So I want to flip that image vertically. To flip the image vertically, we need to specify image source name. Initially, we need to specify image source name. After that, we need to specify number 0. In the flip function, if you specify number 0, that is nothing but we are flipping vertically. That means we are inverting the image. Simply, we are inverting the image. So after that, in the flip function, so after that, we need to show that image. After showing that image, it needs to wait till pressing any key in your laptop. So if you specify -1, so if you specify -1, both the operation takes place at a time. That is nothing but first it will perform horizontal flipping. After that, it will perform vertical flipping operation, and it will give the result. So here, if you specify -1, it will perform this action. So after that, we need to show that image also, and it needs to wait till pressing any key. After that, after pressing any key, it needs to destroy all the windows. So here I want to execute this portion. So here it is our original image. In this image, person holding the ball in right hand. In this image, person holding the ball in right hand. So here I'm clicking on enter key. So whenever you click on this enter key, if you observe the difference between both the images, so here this image is flipped horizontally. That means, so it is looking like the human, that person holds the ball in left hand. It will become like that. So here it is nothing but horizontal flipping operation. After this, I'm flipping enter key again. So here, if you observe this image, so here this image will be inverted. So this original image will be inverted. So these are the three different images. After this, again I'm clicking on enter button. So here, if you observe this image and this image, here only vertical flipping takes place. Whereas coming to this image, both the operations takes place at a time. In this image, flipping as well as, sorry, horizontal flipping as well as vertical flipping operation takes place at a time. So now, if you press any key, all the windows will be destroyed. If you press any key, all the windows will be destroyed. So here, all the windows will be destroyed. So now, so I want to vary the brightness of the image. So like we have different kind of problems like detecting edges, such kind of things. So we need to perform that kind of operation. So here, as I already told you, whatever the image you specify to the machine or computer, that will, for the machine, it will be understood in the form of 0 and 1s only. For the machine, machine will understand this entire information in the form of 0 and 1s only. So I'm getting some disturbance from you guys. Can you please keep your microphones in mute mode? So here, yeah, we need to perform different operations on the image. We need to add some pixels and we need to subtract some features. Finally, I want to observe the image. So whatever the image you take, so that will be understood to the machine in the form of numpy arrays only. So for that purpose, I'm taking help of numpy arrays. Initially, I want to read the image. I am reading the image. So here, if you don't specify the number, by default, it will take same image. That is nothing but original image. So after that, I want to show the original image first, and it needs to wait till pressing any key. After that, here I am creating one matrix by using numpy syntax. So here I want to create one matrix with all ones with the size of image shape. So whatever the image size is there, with that image shape, I want to create one numpy array. I want to create one numpy array, and for each and every value, I want to take in the form of unsigned integer 8-bit. So here I want to represent each number with this extension. After that, after creating one numpy array with the image size, I want to multiply all the ones with 120. That means everywhere with the respect to the image size, we have values as 120. So here, whatever the image size is there, for each and every location, we have pixel value as 120. Now, I want to use add function. I want to use add function. On image is nothing but our original image. So here, I want to add all these pixels to my original image. So here, I want to add this matrix that is nothing but 120 pixel at each and every intensity value of the original image, and I want to see the result of the added pixel image. So here I want to represent that image. For that purpose, here I'm using show function, and here I'm keeping title of that image, and here I'm specifying the image name. We stored that image name in the add only, that's why I'm specifying that thing. So it needs to wait till pressing any key. After that, it needs to proceed to next line. At the next, I want to remove the features. That means to remove the intensity values or pixel values from the specific location, we have subtract function. So here I'm using subtract function. So I'm performing the subtraction operation also on the original image only. So from the original image, I want to remove -120. I want to perform -120 and each and every pixel value. And I want to see that image also. Finally, we need to enter any key. After entering any key, it will destroy all the windows. So here I'm executing this portion. So here it is our original image. So here it is our original image. Now I want to add intensity values at each and every pixel. So if you add intensity values at each and every pixel, the image will be looks little bit brighter. So here, if we add intensity values at each and every location, this image will be brighter. And after that, I want to observe the subtracted image. So here, if you subtract all the features, it means this image looking little bit beautiful. So here we are reducing pixel values. That means it will become little bit darker. Whenever you add the pixels, that image becomes little bit brighter. Whenever you subtract the pixels, it will become little bit darker. So here it is the thing. Whenever you press any key in your laptop, this all windows will be discarded. This all windows will be discarded. So here, after that, so by using this OpenCV, I want to perform bitwise operation. So here to plot the rectangle, to plot the circle, we have different functions in the NumPy, sorry, in this computer vision also. After taking those graphs, we can perform AND operation, OR operation, such kind of operations also on those specific images. So here I want to perform bitwise AND or XOR as well as not operation. So initially I want to import NumPy, sorry, computer vision. After that I'm importing NumPy. So here I want to create one NumPy array. So here to create a rectangle or to create anything, initially I'm taking help of NumPy array. So here I'm creating one array with all the zeros with the size of 200 cross 200. So after this, I want to take all the values in the form of unsigned integer 8-bit representation, and I want to print rectangle. So here the rectangle. So here it is looking like square only, right? Dimension of the rectangle is 200 cross 200. 200 cross 200 dimension means it is a square only. So here we are initially plotting the square. After that, to plot the rectangle, we have rectangle function. In the CV2 we have rectangle function, and we need to plot this rectangle with this specific dimensions. We need to plot this rectangle with this specific dimension. So here I am specifying original dimensions. After that, here we need to specify the values. Here we need to specify the values. So these are nothing but x1 y1 x2 y2 values. So here these are the different points values. We need to join all these points x1 y1 as well as x2 y2. Here we need to specify the color as well as thickness. Here we need to specify color as well as thickness. So after specifying this thing, we need to show that rectangle. We need to show that rectangle. After that, I want to create a circle. So here, after that, I want to plot a circle. To plot the circle here, again, I'm taking, so here, this is nothing but to take a specific box. That is nothing but to take a specific grid. For that purpose, here I'm specifying the dimensionality. It is to take a frame. To take one frame, we are using this zeros function. So after this, here after creating, so I want to create the circle in the specified dimensions. In the 200 cross 200 size frame, I want to create a circle. To create a circle, we have circle function. So in the circle function, here I am specifying circle. So I want to construct this circle in this specified frame only, 200 cross 200 frame only. So in the circle also, we need to specify center. So at which place I want to take the center. So here 100 cross 100. And what is the radius of that center? And which kind of color and thickness? We need to specify color and thickness of the circle. So if you specify color equals to 255 means it will plot the border with black color. So it will plot border with black color. And if you say 0 or below 127 means it will plot the circle with white color, and it will fill entire circle with black color. So here, yeah, madam will forward you the one more link, or else I will forward you the link in the group. Join in the session first, so that we will discuss few more functions corresponding to this thing. So here finally I want to show the circle. After that, I want to perform bitwise AND operation on this rectangle as well as circle. Bitwise AND operation on this circle. So here bitwise AND function. After that, I want to show that image. After that, I want to perform bitwise OR operation and I want to show the image. After that, I want to perform bitwise XOR operation and I want to show the result. After that, I want to perform NOT operation on. So here I want to show NOT operation on rectangle, and I want to observe. I want to perform NOT operation on the circle also. So here we will see the output of this entire thing. So if you observe that thing, so here